Hi, my name is Nick and I'm here today with Lewis, and we're going to talk about the difference between rendering for games and film. Rendering for both film and games have been around for some time and are nowadays fully integrated into our lives. CGI, or computer generated images as it is called, is seen in almost every aspect of television, whether it be commercials, television shows or film. Games have always been created with CGI, and sometimes they use live action cutscenes instead of CGI. Look at the Red Alert series or the Command & Conquer series, where the cutscenes were filmed instead of created.
The USSR is at death's door, comrade.
Which is why we must hurry.
The first rendering that has been done for the film goes back to 1973 to the movie Westworld, where a gun-slinging android had robot vision. From there we have come a long way with motion pictures as Star Wars, Star Trek II, Indiana Jones, Jurassic Park, Toy Story, The Matrix, Lord of the Rings, Avatar, and of course this year's Avengers. Just to name a few where rendering computer-generated images have played a major role in its success. Games, on the other hand, always relied on CGI. In the early days, where games began to emerge, the first games were very pixelated and didn't show a lot. Not like in the 1973 movie Westworld, where the android had robot vision. One of the first games ever created was the game Space War in 1962. In 1970, the first game that gained popularity was Pong. From here we got games like Pac-Man, Wolfenstein, Mario, Myst, Tomb Raider, Sims, World of Warcraft, and this year's God of War. One of the differences between rendering for film and games is that for film, when there is live action and real people involved, the CGI always needs to be as real as possible, as highly detailed as possible, creating large files in the process. For games this is different. Games rely on a game engine to render their images and simply cannot be as high detail as for games. We want to, but we can't just yet. But what is rendering actually?
Rendering is the process of generating a 2D or 3D photorealistic or non-photorealistic image with the help of a computer program. Such an image is also called a render. Such an image is created by having a scene file with objects in a defined language or data structure. The file needs to have geometry, textures, lighting, cameras, and shading information. This file is then processed by a rendering program, which outputs to a digital image or what we call a render. Rendering is widely used by film and video games, but also in architectural designs, simulators, TV shows, and design visualizations. Rendering can be explained in two categories: pre-rendering and real-time rendering. Pre-rendering means that you render everything ahead of time. This method is very CPU or central processing unit demanding and can take a lot of time. Most of the time, this way creates more realistic images and is typically used for film.
You must be popular with the children.
Real-time rendering means that the rendering is done on the fly. Some engine is used to render everything in real time on your screen, where a high level of interactivity is required. This is very high demanding of the GPU or graphics processing unit. After these main categories, you can split this up into two types of render engines: biased and unbiased. Biased is best suited for creating physically accurate images in the least amount of time, and unbiased is best for when you need true physical scientific calculations and don't care about how much time it'll take as long as it's perfect. Some other and often specialized rendering methods have been developed, like scanline rendering, ray tracing, or radiosity. In a nutshell, all these methods do something very good and something very bad. In the end, it just depends on what you need.
Pre-rendering is that you render a single frame by a render engine like Arnold or V-Ray, or multiple frames, frame by frame, and later you composite that into an animation or film. Some render engines prefer to render over the GPU, but most of the time the CPU is used. It can take many hours to render out a few seconds of animation and is, unlike real-time rendering, not interactive. The visuals, however, can be outstanding. You need to keep in account many things when rendering. First and most important is the resolution. To what device are you going to show it? If it's only mobile, then the resolution won't need to be so large. If it's going to be theater, then you need to make it large. You don't want a pixelated movie on your screen. Second is file size. Every frame you render will be a large file, and since you need, let's say, 24 frames for just 1 second, you will have 24 big file sizes of 1 second of film. You need to have a large hard drive, which can store these files. You also need to think about if you want to render it out in passes, like the ambient occlusion pass, or the shadow pass, or the ambient light pass, or many more. The upside to this is that when you render like this, and the shadows aren't the right color for instance, you can manually tweak that pass only instead of re-rendering the whole thing. All passes are then composited into the frames you need. A major difference with real-time rendering is that pre-rendering won't let you see anything until the rendering is done. It will have a far better quality of things. Reflections, lighting, shading, textures, everything can be rendered out in perfection. The downside to this is that you will need to have power, a lot of power, and a lot of time. Games also use pre-rendering techniques. Look at the cutscenes between missions. Those are like the movies. Pre-rendered frames composited in each other to make a short animation. Every game has them, but with the next gen and the hardware getting better and better, is pre-rendering for games still a thing?
Real-time rendering is rendering a 2D or 3D image on the fly. That means that a specific engine renders out the images in real time on your screen. This is the case with games where you can play in a specific world. It's all about the interactivity, whether it be for games, VR, or mobile devices. The environment, the lighting, the physics, the textures, everything is rendered out your screen in real time. This is very high demanding of a GPU or video card. The consoles like Xbox and PlayStation already have a video card installed that can smoothly run all these games in real time. For a PC, you need to buy a good one and install it. Real-time rendering used to be a bit crappy compared to film. Since real-time rendering needed to render the image right away on the screen, they were highly depending on the hardware given to do the job. That's why the games of a few years back look pretty blocky compared to today. In a film, this is different. It doesn't matter how long the render engine takes with one image, as long as it looks good in the end. But with the major improvements of hardware these days, real-time rendering has become a thing, and eventually it might even beat pre-rendering since it is so much faster. In architectural visualizations, it is already in a race with pre-rendered images. Having the ability to walk inside a living room with dynamic lighting and reflections, which all look photorealistic, of a house that hasn't even been built yet is a major outcome for real estate agencies. Games also thrive on this new hardware, especially with VR, when you put on these goggles and you look through them, giving you the feeling that you're actually there in the game. Games are just so much more realistic nowadays, and that's because better hardware means better geometry. A normal game character before the next-gen consoles would have about 8,000 polygons. With next-gen, it's about 40,000 and up to even 120,000 polys per character. That's a huge difference in quality. Your game will look so much more realistic with these polygons. Take the cutscenes for instance. The short little movies at the beginning and end of a game and in between levels that tell you something about the game. Since quality is getting so much better, the cutscenes won't even need to be pre-rendered anymore. They can all be real-time, which leads to another major plus point. Normally you would see a cutscene and then after the game starts you notice that the graphics are somewhat poorer than the cutscene. When everything is real-time, you can play with the characters as they look in the cutscenes. For me, that's a real deal breaker. Hardware keeps getting better and better, and it's a matter of time before movies or parts of movies will also incorporate real-time rendering. It's just so much faster.
What is the relationship between film and games? Games and films influence each other more and more. Game developers still utilize storytelling and film techniques. Games like Tales of the Borderlands and all the Telltale games are still taking the episodic approach to keep players engaged, just like a TV show. Because games are so extremely popular, it only makes sense that Hollywood is also releasing films based on games. Take the Warcraft movie, Assassin's Creed, Tomb Raider, or the Final Fantasy movies. They are all very popular. It's an exploding trend and we will see many more films based on video games in the future. Of course, it's also the other way around. Great movies have been made and out of those movies came great games, like Harry Potter or any Pixar movie. The movies always look great with their special effects and incorporated CGI, and games wanted to have the same. Thanks to improvements in computer hardware, you don't see much of a difference anymore between games and film, apart from the fact that games are interactive of course. Both have incorporated the mocap suit. Andy Serkis, who plays Gollum from Lord of the Rings, is a good example of how the suit is being used. Every nuance of an actor's performance, like movement and facial expressions, is recorded. This data is then applied to a 3D model. This model then behaves exactly like the actor, giving the 3D character lifelike movements without having to manually animate the character. This is where film and games come so close to each other. Video games have finally earned respect for the stories they tell among filmmakers, even for those who don't play games. With the arrival of virtual reality, it may be possible that video games might surpass film as the go-to entertainment source.
So what is the difference between rendering for games and rendering for film? Well, we know that both film and games use pre-rendered images. These are the ones that take up the most time to create, but these renders will also be the ones that visually outstand everything else. It's just about how much raw power and how much time you're willing to spend on it. But with the hardware getting better, real-time rendering is becoming a thing, and since real-time rendering is instantly shown at your screen, you can immediately make any changes to something which is incorrect, and you will see what it looks like on the fly.
Pre-rendered images in film is still the way to go create CGI. Sadly, films take a lot of time to make. Not only in the filming part, which is actually the least time consuming, it's the CGI part and the compositing part which takes up the most time. In the future, when the hardware is even better, we might see CGI for films created real time, which then leads to interactive movies. The biggest difference between games and film is the interactivity. In games you can interact with your character and the environment. In films, the movie takes you on a roller coaster through the film where you can only feel emotions. So how cool would it be to have an interactive movie where you can decide what happens in the movie? There's a difference in rendering between games and films, but in the near future, there won't be anymore. Thanks all for watching. If you liked it, please press the like button. If you want to see more in the future, please hit the subscribe button. See you next time.